Hey everybody, welcome back to another YouTube tutorial. My name's Game Dev, and today we'll be taking a look at this day and night cycle. So if I hit play and press F8, I can actually see the sun goes ahead and sets over there. And then on the other side, the moon comes up. And then when the moon is fully up, a day is completed. Now, what makes this day and night cycle special is that this day and night cycles can actually take in real world locations. So I can feed a latitude and longitude that can actually affect how the sun will set and rise depending on what real world location you give it. You can also give it a real world time zone, and you can even turn on daylight savings time if you really wanted to. What's also special about this day and night cycle is that it actually simulates an entire year's worth of day and night cycles. So every day your player plays, the sun will actually set and rise from a different position, mimicking real life where the sun actually moves a bit from Earth. Well, of course, that's not precisely how it works, but you get the gist of that. So, without further ado, let's get into the video. Okay, so the first thing we have to do is actually import a plugin into Unreal Engine. It is a plugin that comes with Unreal Engine, and it's called Sun Position Calculator. Now, if you haven't heard about the plugin, it's a plugin that takes in real-world time like years, months, and days, and converts it into an accurate, or mostly accurate, sun position, so that we can make the sunset and the sunrises a bit more accurate. So, to import that plugin, you want to go to top left, go to Edit, go to Plugins, and then you want to type in Sun Position Calculator, and you're going to just click this tick box over here, and then you want to press Restart Now. Of course, the engine has to restart, so see you guys then. Okay, and now the engine has restarted, and we have our plugin installed. So all we want to do is close the plugins menu and actually use the plugin. So the plugin comes in the form of a blueprint that actually has a sun and everything included. So the first step we have to do is actually delete all the stuff relating to lighting in this level. So we're going to go to the outliner here in the top right, search for a lighting folder, which is this one over here. And we want to delete the directional light, exponential height fog, post-process volume, sky atmosphere, skylight, SM sky sphere, and volumetric cloud. So we want to delete all of those. And we'll have a pitch black level. So to add the sun position calculator, we can go to top left on this button over here. And then you want to go to lights, and then you'll find the sun and sky. So if you drag this into your level, then you have a very bright sky, but then you actually have the sun and everything in your level. Now, this is already more brighter than it usually is, and that sun looks very small. But what is the problem here? Well, the problem here is that the sun is currently a very high value. Because this plugin is usually used for simulating architecture, they actually use accurate sun values. And the accurate sun value, let's go check. We're going to go to the bottom right to Details panel, and we're going to scroll down till we see the directional light. And here you can see the intensity is 75,000 lux. Now I usually put this at 2.75 lux, so this is pretty high. So before we modify that, we're going to make a custom version of the sun sky that we can modify to our heart's content without messing around with engine files. So, to create that custom sun sky, in the details panel here in the top right, you want to click on this blueprint button, and you want to click Open Blueprint Editor. Awesome. We're going to dock this window. Then, to go to where this file actually is, you want to go to top left, click on Asset, and then click on Find in Content Browser. And here is the Sun Sky Blueprint class. Now, we want to make a copy of this into our content folder. So, this is very important to follow, by the way, okay? Don't don't skip any steps here. You want to scroll all the way up until you find the content folder here in Favorites tab. And then you want to take the sun sky here and drag it into the content folder and press copy here. It's very important that you copy the file, okay? And then we can go back to our content folder, and here's our version of the sun sky that we can modify. Now, to remove all these folders over here, you go to the top right, go to settings, and tick off show engine content over here. Okay, then we can close this sun sky. We can delete this one in the level. I'm just going to click on sun sky, we can delete that. And now we can add our custom one. I'm going to first open up my content browser, rename this one to BP underscore day night cycle. Awesome. And now I can drag it into the level. So let's fix a few of the problems. Firstly, the sun is way too bright. So I'm gonna go to the directional light here in the details panel and set the intensity to 2.75. And of course, it's very dark now, but auto exposure is going to kick in and make it look more like day. Anyway, now I also want to change another thing, and that is I have a bit of a performance issue. And for a long time, I didn't know why I had a performance issue when I implemented this day-night cycle, but it's because of the skylight. So if you go to the details panel and click on skylight, you're going to see the source cube map. Oh, not source cube map. You're going to see cube map resolution. Practically what the skylight is it takes a cube map of the entire sky and reflects it onto objects, but also implements this cool lighting and shadow that makes it more accurate. Now the problem is that this resolution over here is way higher than the default that Unreal Engine has, which is 128. So for me, I changed this cube map resolution to 128. And yeah, that reduces a bit of the quality, but the FPS is way higher. You can also experiment with 256, but that's what I'm going to do now. Okay, perfect. Now we can actually go ahead and add the missing stuff we actually deleted. Firstly, the bottom of the skybox is completely black. The reason for that is because we do not have any fog in our level. So we have to add exponential height fog so that this actually colors correctly. So we're going to expand the details panel here in the bottom right so that we can actually see clear. We're going to click on the BP day night cycle self, click on add and type in exponential. So here's an exponential height fog. If you add that, boom, we actually fixed that. And then we want to go ahead and add clouds. We're going to be using volumetric clouds. So just want to go back to the BP day night cycle self, click on that, click on add and type in volumetric cloud. And now we have clouds. And yeah, this is great. We can now, of course, we made these changes in the details panel, and they aren't in our custom blueprint. So to apply these changes into our custom blueprint, we're going to go to this button over here in the top right of the details panel and click apply instance changes to blueprint. Now the blueprint has a copy of this and it works the same way. Awesome. So now that we have the sun, we need to add the moon. So to do that, we're going to click on the directional light in the details panel, click on add, type in directional light, and we're going to add that. We're going to call this moon. And we're going to go to under light, the intensity, we're going to set to 0.26, which is for me a better value. Now also I'm going to scroll up a bit, and to the rotation, I'm going to go to the blue rotation, aka the Z value, and change this to 180. So now the moon will be flipped from the sun, which of course isn't an accurate calculation for the moon, but it's fitting for what I'm trying to do here, okay? Anyway, We have an error here in the top left of the corner. Multiple directional lights are competing to be the single one used for forward shading. So Unreal Engine is complaining because it doesn't actually know which one you want to set more importance to the forward renderer. Now in this case you want the sun to have forward shading priority. So you want to go to top right, and under moon you want to click on moon specifically. And then you want to go to search bar, type in forward. You're going to find this forward shading priority. You just want to set that to 1. So now the moon has lesser priority over the sun. Anyway, now we can actually go ahead and test how our moon looks. So we're going to click on the BP day-night cycle self. Then we're going to set the solar time here. We scroll down and set the solar time to a lower value. And we can see that our level is actually lighting up with the moon, but there isn't any moon in the sky and the clouds aren't showing. The reason is, even though we have a moon in our level, Unreal Engine doesn't know it's a moon, so we just need to make sure Unreal Engine gets the picture. So, in the bottom right, under details, you want to click on moon, type in Atmos for atmosphere, and then want to scroll down until, actually you want to scroll up, and you'll find this atmosphere light index. You just want to set this value to 1, and now Unreal Engine knows, okay, this is a moon. But there is another problem. The moon is very bright. It looks like day. That's because there's a feature in Unreal Engine called auto exposure. What it does is, based on how bright or how dark the fin is you're looking at, it will actually adjust the brightness to fit to it. So we just want to disable that. There's 2 ways to disable it. There's the more nuclear approach, and there's the approach I'm going to show you that I usually use. So I'm just going to go to the bottom right and save. And then I'm going to go to top left, go to edit, go to project settings. I'm going to type in auto. I'm going to click on search and type in auto exposure. And then you're going to find this setting here. If you take that off, then now the moon actually makes it look like it is night. But I don't like that approach. That's a bit too nuclear for me. I'd rather use a post-process filter. So what I'm going to do is I'm going to go to top left of my screen, click on quickly add to the project, then go to volumes, and then I'm going to go to post-process volume and drag that into my level. Now I'm going to remove Atmos from the search bar under details and type in exposure. And I'm going to find this exposure settings. There's metering mode, auto exposure histogram. That's fine, but we're looking for the min EV 100 and the max EV 100 setting. So if I click on these, the closer these values are to each other, the less of a fluctuation will happen between the light and the dark. You can set both of these to 0 to disable them. Now, of course, it's still bright because if I go into the box, it takes shape. We need to make sure this box actually works across the entire level. For that, you want to remove expose from the search bar and type in unbound, which we're not going to talk about Need for Speed now. Anyway, there's infinite extent unbound. You just want to tick that on, and now everywhere I am in the level, this post-process has an effect. So let's go back to our BP day-night cycle, and we remove this from the search bar. We scroll down till we find solar time, and now you can see we actually have a good looking moon and sun. I think one setting I'm going to change before we actually get into the day-night gritty of it all. I'm going to go to the moon, and I'm going to under light look for use temperature. I'm going to set the temperature to 12,000. This makes it a blue hue, which I find more fitting for night scenes at least. It looks better for me, but of course it's personal preference. Anyway, now onto the day and night cycle. So you want to, firstly, we want to apply the settings we did here into our blueprint. So we're going to go to the top right in the details panel and click apply instances changes to blueprint. Now if I open up my blueprint and dock it, go to my viewport, all the stuff we did into the level is now here. So I can press save, and let's go ahead and implement the day-night cycle. So, in the event graph, we're going to go to the top here and type in begin play. Okay? And on begin play, we're going to make a timeline that will actually set the day-night cycle. So we're going to type in add timeline. Perfect. And this timeline we're going to call day-night cycle timeline. Okay, and this timeline will simulate 0 to 24 hours. So we're going to open it up. We're going to go to the top left and set the length to 24 to simulate 24 hours. We're going to set it to loop so that it repeatedly goes through the code. And we also want to go to the top left here and check on use last keyframe because I have a specific plan for that later on. Anyway, we're going to go to the top left, go to track, add a float track. We're going to call this time. We're going to right click, add a key to curve float, set the time to 0 and the value to 0. Then we're going to add a key to curve float again, set the time to 24 and the value to 24. So when the time is 0, then it will be 0. When the time is 24, it will be 24 over here. Awesome. So we can go ahead and go back to the event graph. And now we can plug this time variable into the solar time to actually set the solar time. So we're going to go to the bottom left under variables, go to solar time and drag that in here, get a set node and plug in the time in here. And on update, we'll update the solar time. So let's compile and save and hit play. And what we should see is that the moon goes down. When the moon goes down, the sun should come up. Awesome, so we already have the basis of the day-night cycle, but there are a few problems. The first problem is there's for some reason a jitter. Now it's hard to see if you're not using like a moon texture, but there's like a random jitter when the sun rotates, and I find that to be an error in the way this plugin calculates the time it should be. So here's how I would fix it. So in the bottom left under functions, you want to go to update sun, and here at this node here, get 8 hours, minutes, seconds from solar time. I find this to be inaccurate for some reason, and what I found fixes the jitter is by going and dragging off solar time and typing in from hours, and then right clicking on the return pin and splitting the struct pin. Now you just want to plug in the hours into the hours, minutes into the minutes, and seconds into the seconds of the get sun position, and then of course you want to connect the get sun position to the sequence node. And yeah, I find this just to work better for some reason. We can also actually take this and move this down over here for cleanliness. Awesome. So we can compile and save, and that is fixed. But the thing is, now we need to fix the fact that the timeline, we can't actually set how long the day-night cycle is. So if I hit play, the day-night cycle is always going to be 24 seconds. How can I make that customizable? Well, it's pretty easy. We want to go to the begin play and drag that away a bit. Then we want to go to bottom left under components. We want to drag in the day-night cycle timeline and get it. Then we want to drag off that and type in set rate. And we're going to find the set play rate node. We want to connect that before we play the day-night cycle timeline. And practically, the play rate will determine how quickly this timeline actually plays. So it works based on increments of 1. So if the play rate is 1, then this will play at 24 seconds. If the play rate is 2, this will play at 12 seconds. And if the play rate is 0.5, it will play at half speed, so it'll play 48 seconds. So now we have that in mind. This timeline is 24 seconds, right? So we need a way to negate the fact that that is 24 seconds so we can make our computations easier. So we're going to drag off the play rate and do a multiply. And we're going to make the bottom one 24, so that no matter what, we multiply 24, so we ignore the timeline speed. Okay? Now, we need to divide a value into 1, because remember, the lower the play rate is, the longer this timeline will play. So, we're going to drag off the 0 value and do a divide. And the top one is going to be divided into 1. Awesome. So that will just get the values into the range we want. Now the bottom one, we want to get the seconds that we want to play this. Because what this code practically did here is it took this and converted it into a second. So that means that all we have to do is multiply this value with a second. So we're going to drag off the 0 value and do a multiply, right? So the bottom one we're going to change to 60 because that simulates 60 seconds. And now the top one will be minutes. So the top value here is how many minutes you want the day-night cycle to last. So we're going to firstly set this value to, I know GTA Online I think does 48 minutes for a day-night cycle. But of course you can do anything you want. I think for this case, I'm just going to put it to 5. Then I'm going to drag off this and promote it to a variable. We're going to call this total day night time. So this is the total time the day night cycle will be in minutes. We're going to go to top right and set it to private. We're going to bottom left and set it to public here so that we can edit it in the editor. And then we're going to go to the category here in the top right of the details panel and set it under time so that it is grouped up with solar time. Anyway, now we should see if I compile and save and hit play that now the moon moves way slower than usual. So this day-night cycle timing thing now works, and if I go to the bottom left, I'm going to just scale that bottom right to the details panel. Now I can actually set the total day-night time. Let's say it's set to 20 seconds or 20 minutes, and now you can see that moon moves really slowly. But yeah, that's sorted. I'm going to leave it at 1 for testing purposes. Now, the problem is we have one more bug to fix, and that is actually not a bug. It's unfortunately the way the real world works, right? So, when the sun sets and when the sun rises every day, it doesn't do it at the exact same position. The sun moves around a bit in real life. Now, the thing is that if we just change the solar time repeatedly, we repeat a day. So the moment we change from 12 o'clock to 0 o'clock, aka resetting the day-night cycle, there's going to be a bug where it jumps around because, well, the sun position at the morning was different than the sun position at night. So what we need to do is we need to simulate entire years worth of day-night cycles to compensate for that. It also gives us the advantage of being easily being able to add stuff like seasons, and overall it's just a nice touch that the morning can rise at different times. So let's go ahead and do that. We're going to go to BP Day Night Cycle. I'm going to just move this to clean it up a bit. And what we're going to do is we need a way to know if the day has actually finished. So how we're going to do that is by dragging off, okay, well, we can't drag off the finished pin because the finished pin, it doesn't work when your timeline is looping. So we need to make our own finished pin. To do that, we're going to open up the day-night cycle timeline. We're going to top left, go to track, add a new track, change it to add event track. We're going to rename this to day ended. We're going to right click add a key to curve float, set the time to 24, and set the value to 0. The value doesn't matter, but I just think it looks better. Anyway, you can go to our event graph, and now when 24 hours is hit, or we get 24 hours, the day ended is called. And now we can actually progress on the date in the year, okay? So, we're going to go to the bottom left under functions and add a new function. We're going to call this update date. So, now we actually need to know what day it is. So in the bottom left, under date, here in the variables component, we're going to go to the day and drag that into our level, and now we have the day variable. So when update date is called, we take our day variable and +1 to our day variable. Now, of course, we need to know if this day +1 actually is more than there are days in the month, so that we don't make it the 32nd or something stupid like that. So, to do that is pretty easy. You drag in the month variable here in the bottom left, get month, and type in days in month. So this node will actually return how many days there is in a specific month. So you just want to disconnect the month variable and connect it to month here. And the year, we want to go to the bottom left and drag in the year variable. So based on what year it is, it will determine how many days are in the month. That's because there are stuff like leap years where there's an extra day in February, and that will account for that. Anyway, now we can go ahead and actually work on this. So, if this day +1 is bigger than days in month, then we should go to the next month. So, we're going to drag the days in month down here. And if day +1 is, we're going to make a greater node here. The day +1 is more than the days in the year. We have to go to branch. We make a branch node. And then we go to the bottom left of the day, drag that into our event graph. Set day. We're going to copy that and paste it to the bottom. So if the days +1 is bigger than month, we set the day to 0 because we're going to the next month. Else, we take our +1 variable and just continue on with it. So we connect that to the false. Awesome. Now we actually went to the next month, but we didn't actually do it in code. So we need to progress this month as well. But then we have to do the same amount of checks we did for the day to determine that we're not going ahead and setting an invalid month. So what we're going to do is we're going to do about the same thing. We're going to go to the bottom left, drag in our month variable, get month, then do a plus node, then do a +1. And so once day is going to 1, that means that's the next month, we add a month. Now we need to know if adding a month is bigger than the total months in a year. So what we're going to do is we're going to drag off the month variable and do a greater. So if month +1 is greater than 12, aka it is bigger than the 12 months they are, then we're going to drag off that and make a branch node. Then we're going to connect that. And if this is true, I'm just going to reposition this a bit. If this is true, that means that we have to reset the month we are in. So we're going to go to the bottom left, go to month, drag that in, get set month, and the month will be set to 1. Awesome. But if this is false, that means we actually move to a valid month, and we just connect this +1 month in here. I'm going to just reposition that a bit. Awesome. Just going to move that down here. And now both of these I'm going to comment. So I'm going to select all the month code here, press C to comment. I'm going to call this progress month. Awesome. I'm going to drag all of these here to the left, select those, comment, and call this progress day. I'm going to move the update date out of here. Okay, so this code here is all we need. We can compile it, save. We can go back to our event graph. I'm going to just close all of these. Awesome, and now we can move our update date function in here. So we can drag our update date in here and connect that to the day ended. Awesome. Now, one more thing I'm going to do is that on event tick, we check if the position of the sun actually changed. Now, this check is unnecessary because when we're calling update, this will be called anyway. So we're going to delete this code here out of tick and move this code into the update here, so that every time update is called, it will call this code, which is what it's supposed to do. Okay, I'm going to now do a bit of cleanup. I'm going to select the play rate and everything here. I'm going to press C and comment this and call this change speed of day night cycle. Gonna drag that over here, and awesome. And this I'll just call day night cycle. Going to move this up a bit. I'm going to make it encapsulate everything we're going to do in the day night cycle. So this one I'm going to move down a bit. I'm going to move this up a bit. Awesome. And this will now include everything we're going to do with day-night cycle. Okay, now that we did that, we need to actually test our day-night cycle code to make sure the day actually progresses. So to do that, all you have to do is go to the total day-night time and set the value like really low so that the day and night cycle loops really quickly so we can actually see the days add on. So I'm going to hit play, press Shift F1, click on the day-night cycle. And then I'm going to see that the day increases every single day. So it's going to do it once more. Perfect. So let's test if it actually moves on a month. So I'm going to set the day close to the end. So 29th. I'm going to hit play. Shift F1. Go to the BP day night cycle. And let's see what happens. There's one more day it needs to do. And then it should go into the next month. So let's see if it does that. Awesome. So it's in the next month. So that code's fully working. Now it's just a few more small quality of life changes. Here in the panel, you can see the solar time only goes from 4 to 22, which of course day is 24 hours. So we just need to actually make the slide bigger. And I also need to fix that spelling error I made. Anyway, we're going to go back to our BP day-night cycle. Then we are going to go to the bottom left, go to the solar time variable here, go to the slider range here in the top right of the details panel, set that to 0 to 24. So now we can actually set that value. Anyway, I'm actually going to set this value to 24 as well. It doesn't really matter, but I'm going to do it anyway. Anyway, now we can go ahead and fix the spelling error over here on the bottom left under total day night time. I just want to change this to total day night time. Awesome. You can compile and save. And then one small quality of life change is that when I change the solar time... Actually, wait, never mind. This, wait, actually, let me just test this. If I change the solar time here, it doesn't continue off of it. So no matter what time I set here, it still continues from the beginning of the day. So how do we fix that? We're going to go to the BP daylight cycle. We're going to go to the construction script. We're going to delete update sun. And all we're going to do is just call the timeline. So what we're going to do is we're going to get our solar time. Then we're going to go and get our day-night cycle timeline. And we're going to drag off the timeline and set time. I believe set play back, oh yeah, set playback position. So then we set the solar time to the new position. We don't have to worry about firing events or anything like that. We can just go ahead and run this executable. So what happens is that every time the solar time changes in the editor, it will actually run the day-night cycle in our event graph, so that no matter what we change the value to in the editor, it will continue on from it. So now you can see if I set the value to morning, it's going to continue off morning. If I set the value to day, it's going to continue off day. Now I can go back and change the total day-night time to something more reasonable, like 20 minutes. And here is our day and night cycle. It is fully working. We have a date system. We have all that going on. And yeah. Okay, so before I forget, I've been forgetful through a lot of this tutorial. This plugin actually supports input of a location in the world, so that you can accurately do sun position based on where this level is in the real world. So if I click on this plugin, then there's going to be this location setting. There's latitude, longitude, time zone, and north offset. So how do we actually get the values of a real world place? So the first thing you want to do is have Google Maps open, and then you want to go where you want to be in the world. For me, I'm going to take Venice, which I hope I pronounced correctly, but I'm just going to not worry about that. So you take any place in the world you want to copy, you just right click on it, or you can right click anywhere on Google Map, and you can just get these values over here. So I can left click on them to copy them to clipboard. So the latitude is, let me check, just remove, we don't have to worry about being too precise, so it's 45.44. Okay, and the longitude is 1231. So I can just change that to 1231. And currently, at the time we're at, this will be night now. Now, this is still incorrect because of time zones. So the place in the world actually has a time zone. And to get that, you can go to this website, Time Zone Map. I'll have a link to this in the description. But what you do is you search for a city that you want to mirror, and then you can actually find out the time zone. So Venice is over here, and it's in the green part, and the green part over here is +2. So the time zone would be +2. So here in Unreal Engine, the time zone should be 2. And so now we have a more accurate simulation of the time of Venice. So we'd have a more accurate simulation of where the sun would be positioned. And then finally, one more thing is you can have daylight savings on or off, depending on what place you are in, because some people have daylight saving time. So you can just go find out if the place you have daylight saving time. I don't think Italy does, so I'm not gonna worry about that. And then finally the north offset. So adjusting this affects where north is on the level. So if you had an angled level, then you would just change the north offset to make sure you have the rotation in the correct place. So you can even see the compass here. It rotates to show you where north in your level is. Okay? And yeah, that's all you really need to know to get more accurate sun positions. And yeah, that's it for the tutorial, guys. Thanks for watching. If you like the content, please subscribe. Hit like if you liked the video, hit dislike if you didn't, and see you guys in the next one. Goodbye, everybody.